All right. So first thing is that you need to prepare your CAD file if you will import from CAD to ETABS. You need to prepare your CAD file the way that I did it. And I have the columns. And what I'm going to do, I'm going to draw a line in the middle of the shear wall that helped me to draw the shear wall in ETABS. So I don't have to create grids. So I will like activate maybe a layer and I will call it beams ETABS. And I'm going to draw a line in the middle of this wall. Right, and a line here, and another line here. So I draw a line in the middle of the shear wall. I'm going to draw another line in the middle of this shear wall. But I want to make something that tell me where is the middle at. Okay. Let's deactivate Z things because it keep messing around. Okay, I'll make a line here. So all these is just a small lines that will help me to catch the middle of the beam, the middle of the shear wall, and I will draw something from here to here. Wait. Okay, yeah. So yep. All right. So right now my AutoCAD file is ready. And what you will do is you will save as, and let me save it as today's date is 14. Let's make it trial. And I will save it as a DXF. DXF is much better than DWG. And you can do it both, but DXF will be much better. And I will save as DXF, and you will have to close your file because if you didn't close it, it will not get imported to ETABS. So I will close the file. And then you will open ETABS. And then I will say File, New Model. And a new window will open. And what I'm going to do, I'm going to change the units because I will work metric. So all our units will be meter and kilonewton. So I change it from US to metric. And for the other things, it doesn't matter because we are not going to the design. So we don't have to pick the design code, either ECI or Isaac for steel. So I will just make this metrics and I will say, okay. And then I will ask you if you want grids or not. I don't want grids, but I will make it blank because I already have the AutoCAD file. I need the grids. You can modify the grids. Actually, if you see it, it's much easier for you. I give you the spacing in X direction. It's 2.5, and you want to make the spacing 2.5 in X and 2.5 in Y, and you draw the column by yourself, do it. But if you want to use the AutoCAD, follow what I want, what I'm going to do right now. So let's assume we are going to do 60 stories. I will put 60, and I'm going to make the typical story height 3 meters. So all of you is going to make the story height 3 meters, and the bottom story 5 meters. Like the first story 5 meters, and all the other stories will be 3 meters. Okay. And then I will say blank and okay. All right. So now before I import my AutoCAD file, I'm going to do some definitions that we used to, like define the material. And let's use the material, the concrete material defined here. The one that you used in all your homework. Yeah. The one that you used in your homework, and the same loads, like the gravity loads will be the own weight of the structure, because this is a residential structure, and 1.92 kilonewton per meter square for live load and 1 kilonewton for flooring. Okay, the same loads that you used in all your homework. You can write this if you don't remember. And then here I have kilonewton per meter cube. So I will keep everything the same, and I will say okay. I'll make sure that my units are consistent, kilonewton and meter. So this is millimeter. I'm going to change to meter. You can keep it millimeter if you would like. And then I will go define sections. So right now I told you that we will have beam sections, for example, like this group, and I made this red. Focus right now. I made this red. That means that this is the original structure. I mean by that, what I mean by that is, like, when you change the coupling beam widths and depths, you don't change the other parameters. Like your core structure is 30 by 50, and you keep it changing all these parameters. Like your spandrel beam will be, because you can make lots of combination. So you will ask me, Professor, how can I change this depths and this is changing in the same time? Should I try 25 with all these and 30 with all these and 40 with all these? No. So you will have this as the basic model. Like when I make, like, the color is red, that means that you have a changing parameter, like the width is keep it changing. But if you encounter other change, use the value that has red color. Like here, if you want to try the model that has 25 coupling beam widths, so you will try it with 30. And 25 with 30, 30 with 30, 40 with 30, and 50 with 30. So let's come to the coupling beam depth. So you have 50, 70, 90. So you will try 50 with a 30 coupling beam depths and 30 spandrel beam depths. What is the difference between the spandrel and the coupling beam? I mean by this is the one outside is the spandrel beam. The one that link these two shear walls together is the coupling beam. So this is the dimension for the beams in the outside will be different from the dimensions from the beam that couples the shear walls. But you know what? I put them actually the same, but you will have to try different ones for the size of 30. So the only things that is changing is the spandrel beam dimension and the coupling beam dimension. So these are the only two that are changing. And for the outrigger, it's just something constant. You will try your structure with your main structure that has 30, 30, 90 without without outrigger, and with outrigger. Okay, so you'll finally will end up with modeling. You have 10 or 11 models. Okay, the guys that has 4 in their teams will have 12 models. So it's the best way to divide it is that each one of you have ETABS installed in his machine, and each one of you will take like 3 or 4 models to run so that you can run your model quickly. Okay. All right, so this is one note that I want to make about the project. Let's get back to the ETABS. So right now, let's assume that we have beams 25, 30, 40, and 50, and the depth is 50. So what I'm going to do, I will go to ETABS and make a definition, define, not this one. This is concrete beam. I'm going to add a copy of this property because this is a beam. So I'm going to make a copy of this beam that has dimension. I will name it beam 25 by 50 centimeter. Okay, and I will choose the material concrete, and I will make the depth 0.5 and the width is 0.25. and then I will hit OK. All right, and I add copy of this. And what I'm going to change next is I'll make it 30 by 50. So it will be beam 30 by 50 centimeter. And I'm going to change this to 0.3 and so on. Once I finish this, I will make another one, add copy, and 0.35. Let's see what we have. Yeah, beam. I believe it's 40. Yeah, it's 40. So I'll make a beam 40 by 50 centimeter. And I will change this from 0.3 to 0.4, and I will say okay, and you make the one that is 50 by 50. And once you are done, you hit okay. Same thing for the slab. All of you will have a slab thickness that is 30 centimeter. And I put it here. So I'm going to define section and then slab section, and I'll make sure that I select slab, add a copy, and then I will name it slab 30 centimeter thickness. I make sure that I'm gonna choose concrete material, slab, and the thickness is 0.3, and I will hit OK. So I define the slabs. Let's define the walls. So I will define wall section, and in the wall section, okay, let's see what we have here. The wall section that we have here is 100 centimeter. So I'm going to define add a copy, and I will name this 100 centimeter, and then the concrete material, and this will be 1 meter, and everything is good, and I will say okay. So I define the walls, and I define the columns. So, but right now you have each 10 stories has different column section. So you will need to define 6 different columns, like here, the column size, and all the columns are rectangle. So when I say 75, so it's a 75 by 75. So I will only define one 75 centimeter by 75 centimeter. But let me measure the columns that I have in my AutoCAD file. I believe it was 0.7, right? Okay. So this one, oh, it's 1. Okay. Yeah, it's 1 meter. Okay, so let's define section, frame section, and you will find here concrete column, and I will add a copy, and I will name this column as column 100 by 100, column 100 by 100 centimeter, and I will put 1 here and 1 here, and I will say, okay, you'll see here how is the cross section is coming together. I will say, okay, you do the same thing, 90 centimeter by 90 centimeter or 70 to define all the cross section. And once you are done, you will say, okay. So I defined everything. You can actually right now start defining the loads, like the load patterns. You'll have dead and live. You can start defining flooring, and you will say it's dead, and here is 0, and add new load and say, okay. Right now, the thing is I need to build a geometry. I define the materials, the sections, the loads, and I need to bring the geometry. I will use my AutoCAD file that I built and I saved it, and I will bring it here. So you will save file, import, and you will find here what is called DXF or DWG file of architecture plan. I want to import this file. And I'll go where I saved my project. And this is the one that I saved, that I'm going to say open. So it will ask you a few questions. We'll ask you about the units that you draw this drawing. I will tell him it's in meter. And I want to put this drawing in story number 1. So the default was a story number 6. And it asks you if you want to, like sometimes you didn't draw with respect to 0 and 0, like you didn't move your model to 0 and 0 in AutoCAD. It asks you, do you want to move it to 0 and 0? Do you want to rotate it? So everything is ready. I don't want to move it or rotate it. And I will say, okay. It's supposed to come, so it will take some time. Like I tried to do it yesterday, it take like 10 minutes until the model come to ETABS. That's why I made several ETABS model. Let's take this, we'll take its time. And after you bring your file, it will be something like this. This is what we draw on AutoCAD. Okay, right? This is the columns, and this is the grids, and this is the shear walls. So do you guys remember how we were able to draw all these columns one at a time? I don't know if I defined the
You assigned it, right?
because I built this, but I didn't define sections. Let's go to, no, I think I defined sections. Frame sections. No, I didn't define. Okay, let me define one section very quick, add a copy, and I'm going to make a beam, one beam that is maybe, let's 50 or 30, 70 centimeter. And it will be the depths 700. I just have a model that I prepared because I know this one will take time until it brings my AutoCAD file. So I have one, but it turns out that I didn't define anything for this one. So I have to do it now. 300, it will be much faster. And let me define one column, add copy. And I believe these columns are 1 meter by 1 meter. Okay, column 100 by 100 centimeter. And I make this 1,000. Right, so this one I didn't make the unit, so I'm going to click. Right, this one is still creating. I go to the units, consistent units, and then this will be meter. Then I'll say okay. All right, so I define the column. So what I will do here, model windows. Yeah, so I will go to my architecture layer here, and I have layer that is column where I draw these columns, and I will right click on this, and I will add column object. So when I add column object, all these columns will be drawn in like few seconds, hopefully few seconds. If you do the grid one, you will have to click column by column. And I believe we have 20 or maybe 25 on each side. So it's like more than 100. So it might take you, when you zoom in and you zoom out and then you miss drawing one column. So it might take you like 30 minutes or something to draw all the columns. But maybe you find that it's a time saving if you, because you are spending lots of time on AutoCAD, and rather than this, I will spend it on creating the geometry on ETABS. Okay, well, let me this one. Okay, let me delete this slab. I just want to save time. Okay, and here I'm going to so let me also delete these so that we can draw them together. Okay, yeah. So once you extrude the columns or draw the columns, it will be something like this, like the one that I draw here. It will turn out to be something like this. And we, like ETABS, will make the supports all hinges. but we are going to use fixed. And why is fixed? Because tall buildings has a very deep foundation, and this foundation is mostly pile foundation that provides fixation for the column. So we are not going to use hinges, we are going to use fixed. So it's very easy. You click on all these hinges and go to assign assign joint restrain, and then you click on fix it and say okay. All right, is that clear? All right, so right now we have the columns are done. So the next part is to draw the shear walls. So let's draw the shear walls together. Actually, for this one, I didn't draw like a line in my AutoCAD file to use it to know where's my shear walls at. So what I did, I drew some grids that helps me to know where is my shear walls, where can I draw my shear walls. So I will show you right now. Let me go up. All right, yeah, here. So right now I'm at the Verista story. I was at the ground. So here right now Z 3 meters. Right now I'm going to draw a shear wall. So I will go click on this view, and I click on this view, and right now this shear walls will be activated. If you are in 3D, the shear walls will be deactivated. Like you need to activate, like to click on the 2D view, and then this one will be activated. Now you can draw shear walls. Okay. So to draw the shear walls, I will click, and then the properties will come here. It will ask me what type of the area. We will call this area not spandrel, it's pier. Okay, for shear walls, ETABS help us to do the coupling beams. ETABS calls ETABS call the walls piers, and the beam that connect this walls spandrel. Okay, so this is how it names. So if you on ETABS said pier, that means that you are drawing a wall that goes from the upper story to the down story. But if it's a spandrel, it will keep asking you what is the depth of this spandrel. Okay, so this is because we cannot in shear walls, it's better to model the connecting beam or the coupling beam as a shell, not as a frame. Because as a frame, these two walls will never feel that there's something very steady that holding them together. But if it's a shell, it adds connection at all this line. If it's a line, it will be only the connection at only one point. So it will not be a coupling beam. So the coupling beam need to be a shell. And I will show you how it looks like in a minute. Okay, so let's see how to draw the pier. So first I have to make sure that I'm drawing a pier, and the cross section of this property is a wall 100 centimeter. And I will start from here. Well, I don't know what's going on. Okay, so right now I think I can draw, because the grids, like you need a snap to like a magnet that takes your point where you want. So right now I just clicked on a snap to find grid, and right now this point is picked. So now right now I can draw the first line, and here is my wall, and I can go here. And this is the end of the wall. And right now I draw the first one. And the second one is from here. Here. To here. All right, yeah, so I'm done with the piers. So let's draw the spandrels. The spandrels, which is the coupling beam. So when I hit spandrel, it will ask me what is the depths above and the depths below. So the depths above the story and below the story. So do we need depths above the story? No, we need depths below the story. So it will be depths below, and you will go to your sheet and know what depths is that you are going to use. So you are going maybe depths, let's pick depths 90. Because you have multiple depths, 50, 70, 90, and 110. So let's pick 90. And I will go to ETABS. And here I'll make the depths below is 90. Oh, sorry, it will be 0.9 because I believe I changed the units into meters. So when I draw here, I need you to look what's going on there. Can you see the beam? Yeah. It's a drone. And I will make another one on the other side. And right now the beam is done. So we are done with the shear wall and we are done with the columns. What is left? The next is the slab, right? So I'm going to draw a slab and I need to change the property. So I will pick slab 30 centimeters, the one that I defined. And I'm going to draw a slab all over my area. Okay, I draw the slab. Let's do the opening. And the opening, all what I'm going to change here is I will make this as an opening and I would draw area and it will be I have an opening here and another opening on the other side. Yes, here. Okay, so I'm done with modeling everything, the walls, the columns. Yeah, and it's still the beams. I didn't draw the beams, I think. Oh, I already drew the beams like when I created this model, but it's a very basic, like let me delete them, select. I mean beams, the perimeter, the beams on the perimeter. So I have beam, this beam, let me select all the beams and let me delete them. Okay, they are deleted. Let me draw them again. So my computer is heavy because I have 3 windows are running. Yeah, so this one is imported right now, the one that we tried to import at first. And this one made the columns. Okay, so you know, guys, what I mean, what I'm doing, because it will take time. Let us close this so that we can save some memory for other things. And let me close this. All right, so we have only one that we are working on right now. Okay, so let's draw the beam. So I have, here's the beam and the parameters will come here, beam 25 by 90, and just you'll draw one single beam that from each corner to the other corner. Right now, I'm done with modeling my project. So all the next will be replicate. You will replicate this story for the 10 stories. But before I replicate, let's put loads, like because when we replicate, the loads get replicated with. Okay, so I select the slab and let me make sure that the slab is selected. And once you pick the slab, you say assign shell load uniform. And let's put live load, and this live load will be 1.92 kilonewton per meter square. And we will say apply. I'm not sure if the slab is selected or not. It says no selected object. So I'm selecting one more time, apply. Okay, and then the next one is flooring, and it will be 1 kilonewton. And I will select the slab and apply and say okay. So right now I have all the loads on the slab, and you can run it and try to like find the results, but I'm not going to run it because it will take some time. But make sure when you run these, you increase the mesh, because this is a very big model and it will take forever to run. So and ETABS, you guys know that it do auto mesh, right? So you will go to analysis, and for one story, this one story, if you want to show the results, you can make auto mesh at 1.5 meter or 1 meter, not 0.5, and run it for this one story. But when you run the entire structure of the 60 story, we are going to make the mesh as the size of the spacing between columns. So for example, if your project has a spacing between columns 3 meters, so you will make the mesh 3 meters. If your spacing is 2.25, you will make the mesh 2.25. Why? Because when you will tell me, okay, why we are doing this? You said like when we increase the mesh size, it will be much more accurate. And when we have like smaller mesh will be more accurate, but if it's bigger mesh, it will be less accurate. This, if we are doing analysis in gravity, we need to know what is the bending moment on the slab. But when we do lateral load analysis, all what we wanted from the slab is its load. How much is the weight of the slab? Because this is what matters in lateral load. If the slab is very, very, like has lots of weight, it will absorb lots of force and it will make lots of displacement. And I'm saying to make the mesh as the size of the column so that we make sure that there is like the spacing between column. You have a column here and column here and column here and column there. So 4 columns. So at least the mesh size need to be the size in between columns, because if it's bigger, the columns will not feel the slab. Like if you have a column in the middle here and you make the mesh bigger than the spacing between column, this slab will never feel that column. Okay, so we need to make the mesh size at least the spacing between columns. All right, so let me replicate this to the first 10 stories. All right, so what I'm going to do, I'm going to view the 3D, and I'm going to go to view and set 3D view, and I'm going to make the 3D view XZ. Okay, so what I did right now, this is a 3D view. You'll tell, no, this is a profile or this is a side view. Yeah, it's a side view, but I'm seeing everything behind. Like if I select all these, so I selected the entire structure because I selected these columns in the front and everything in the back. It's not a 2D view. It's a 3D side view. Okay. And what I'm going to do, I'm going to edit, replicate, and I'm going to do story replicate. And I'm going to replicate this story in which stories? I have 60. I replicated in the whole 60.
No, you go 10.
Up to, I'm going to make to 11. Why? I will tell you right now. Okay, delete the original. No, I don't want to delete the original because I will use 11 to edit and replicate 11 for the other 10 stories. And then I will say, so before I hit OK, it shows you how your structure will be look like. And then you can say OK, and then the structure will start to replicate. And then you use the 11 story to choose the columns only in this story, like this, and assign the new column dimension. Like you will go define section, frame section, and then I will make this column and I will say modify and show property. Let me see very quick what is the okay, I'm doing the 100 centimeter, so let's make it 95. So I make 95 by 95. And I make sure that, because this is the name of the column, not the dimension. So the dimension, you need to change it here, 0.95 and 0.95. And you will say, okay, okay. Then you will assign frame section, and you will assign column 95 by 95. Oh, so let me double check something, because I didn't add a copy. I modified the column. That's what I did. Okay. Did you guys know the mistake? The mistake that I did? Okay. Rather than adding a copy of the column 100 by 100, I modified it.
That's what I thought.
Really? All right. So let's make this column 100 centimeter by 100 centimeter and make this one. And I will say okay. And what I did now, I define new column rather than one that I deleted, but it's still, the columns are 95 by 95. But what I'm going to do, I'm going to select the one that I changed. And I make sure that the top one is not selected. Yeah, and then I assign frame section property, and I will assign 100 centimeter. So to make sure, oh, I didn't select these.
That's in the fall. Are you using the Citrix server right now? Or the Joe?
No, this is the trial version. Can you imagine how slow it is if it was? Okay, let me double check. So this column is 100 by 100, and this column is 95 by 95. So we are good to go. Just like going to, yeah, because this one, like the text will. Yep. Then I changed the columns, and what I'm going to do is I'm going to select the columns and slab, but actually we need also to change the course cross section. I'm not sure. Maybe I want to make it much easier for you guys and pick one core cross section for the entire project. Like, yes. Definitely yes. Okay. So how about if we, so the shear wall cross section is the same. And what I'm going to do, I'm going to change the coupling beam depths to be only 100. How about this? You will not change 4 things, so it will be 100. So right now I reduced your effort 3 times, okay? And how about coupling beam depths for, the thing is, I want you to sense how this will impact the lateral drift of your structure. Like, because I want you finally to make a relationship between the coupling beam depths and how is the structure's behavior look like. But let's focus only on the tube and don't focus. If you guys did this, like, okay, let me make this as a bonus. Okay, so who will try? let me tell you, who will try to change the width and the depth of the coupling beam will get 15% bonus and it will be added towards his final grade.
Oh, wait,
Okay? How about that? Is that good?
yeah.
So if you did bad in the midterm, it will add it to the final. So you can get more than 25 points in this project if you did it, okay? But if you want to stick with the 100-point, you will, let me add another column, another row. And this like will be widths and depths. If you want to only to do one trial, widths by depth. And for this one, okay, for group one, they will do widths of 30 by 100. Okay, well, this will be. Okay, here's the thing. If you want your project to be graded out of 100 point, or like, and this 100 will be 25 points because this is 25% of the grade. So you will use this dimensions, like one dimension for the widths and the depths of the coupling beam. If you want your project to be graded out of 115, so you will need to try all these and you show the results of all of them in terms of a curve. Like you will show me curve that this is how the lateral drift of the structure is changing with the coupling beam widths. And this is how it's changing with the coupling beam depths, okay?
So you're gonna have like four different, right?
No, this will add. What do you mean 60? You are asking about the number of models, additional models?
Yeah.
So this is 4 and another 4. So it will be another 7 models. You need to do another 7 models of the coupling beams. But it's easy. You know what you are going to do? You will select the coupling beam and it change the widths. Like, yeah, like you will define new material, sorry, new section. Yeah, exactly. So did you see what I did here? When I draw the, let me convert it to plan view and let me go to story number 1. What was that? What do you mean by group member?
So group one.
Oh, you guys will tell me and I'll like, you give me the names and I will tell these names as group 1, this names as group 2. That's why I'm asking you to send me the names as fast as possible so that I can, so that you can know your group. Do you guys already grouped each other or everyone has a group? Actually, the 4 people who spoke. Yeah. Okay, so you will wait because the 4 people who spoke, so I believe there will be lots of changes. Okay, so just like, what are you going to do? If you click at this coupling beam, actually, this coupling beam has a wall section. So you will need to define a new wall section, like for example, define section, wall section, and you will name this like the copy, and you will name it a spandrel 50 centimeter. And you will make sure that the thickness of this is 0.5. I mean by the thickness is the width, okay? And then you will say, okay, so you have the widths. And when you draw this beam, imagine that we didn't draw this beam yet. And you will pick, it's a spandrel, and the cross section is a spandrel 50 centimeter. And you make the depths here, like you change the depths here. So you got what I mean? Like that, the spandrel, like the coupling beam dimension, it takes the thickness from the wall thickness, but the depths, you will have to define it before you draw.
Right.
Okay, so this is how you are going to change it. So if I'm saying that you will have 4 spandrel widths, so you will have to define different 4 wall sections that has different thickness. And for each thickness you will draw them with different depths. Like one time you will do it with the depths 0.7, 0.8, 0.9, whatever I assigned it to you.
Hey, sir, but real quick, because if we go back to the spreadsheet, you know how you had those one in red, right?
Yeah.
We doing the spandrel depths, we doing the multiple depths. We keep that.
Yeah, exactly. So you will keep 30, the thickness, the same, and you will draw them.
70, 90, 110.
Exactly.
Got it.
Yeah. Okay, so this is how it works. And I was actually doing the view, 3D view. Let's get back to draw the other tennis story. Set not elevation. Let's view, set 3D view, and I'm going to XZ. Okay, and I was at story number 11. And I'm going to select the story number 11 and replicate it in the next tennis story. But make sure when you replicate, you change also the wall dimensions. Like if you are going to stick with, if you are going to want to target the 115 points, so it changed. But actually,
The projector went off.
I don't know what happened. Right. So, but my recommendation is to start to build the core project, like the one that has dimension 30 and 30 and 90, and then you start keep it changing. You like make the model save as, and you keep it changing the dimension of the width of the coupling beam, the depth of the coupling beam, the width of the spandrel beam. Okay, you keep it changing these. And then once you did all the changes, and then I will replicate, edit, and then replicate to another 10 stories. And this one will go from story number 12. And I do click shift up to story number 21. And I'll say apply, okay. And then you get your next 10 stories. And then you change the columns dimension for the 21 story. And then you replicate for the other stories. And definitely your model will get heavier. And what I do usually to help me if I did a change, like let's assume that you draw your model and you want to make a change. So what we have things that is unique here. What is it? Like you have story 1 and there's another thing story typical, or 9 stories typical to 1, and story number 11 and there's a 9 stories typical to 11. Let's assume that you want to do changes, like you want to change columns dimension or beams dimension or walls dimension, and you need it to happen to all the stories that are similar. How can you do this? You can actually go to the grids, like let me tell you how to do it. You will right click in this space and you will add and modify grids. And you will go to modify and show story data. You will find the 60 story data here. So there's something here that you can call this as a master story. Okay, so story 1 will be a master story to the next 10. So I will make the next 10 similar to story 1 because story 1 is a master story. Let's go to story number 60 and make it off, not a master story. So this will be like 1, and you keep it changing this. how this will help me, this will help you. Let's assume that you forget to assign loads. So you don't have to go story by story and assign your loads. You just assign it to the master story and it will keep assigned to the stories that are similar. Let's say that you messed up drawing a shear wall or drawing a beam. It changed it in the master story and it will be automatically changed in all these stories that are similar. So you go to story 1 and up to story number 10. Then a story number 11 is a master story to all the other stories. So this will be similar to story number 11, and you will keep doing this up to story number 60. Did you guys get it?
Yes.
Okay. And actually, you can change the columns by this. Like you can do what you can do. You can replicate the entire structure, 60, and you make these master stories, and you keep edit the master stories. And once you edit them, they will be automatically edited in the other 10 stories. So this is a one way to do it. Whatever it's easier for you, you go for it. Okay. So is everything clear right now? You guys can start build the model. Okay, let's turn off the projector and let me stop sharing and
Dr. Paul, so you were saying